This is a consolidation video for Unit D, Lesson 5, finding the y-intercept given a point and slope. In all these lessons, we are looking for the y-intercept, what is also known as the initial value. Alright, so to find the y-intercept, we need two pieces of information, right? We need either 2 points or we need a point in the slope. Next lesson is going to be the 2 points. Right now we're doing a point and the slope. And essentially, we're just given the pattern and then a starting point on that pattern. We need to kind of extrapolate to figure out what's going on in the rest of the graph. So when we look at this first one, what is the y-intercept? We have a point at -4, 5, and every time it's going down 1 over 1. So we have another point here. But if the slope is constant, right, the slope is going to be the same for our entire line, then the next point should be down 1 over 1 to go here. Then down 1 over 1 to go here, down 1 over 1 to go here. This gives us a y-intercept of 1. So our y-intercept here is 1. We sometimes will call this a b. Right now, maybe we'll just call it 1. All right, next up here. What is the y-intercept of this table? So we are given a point on this table, 3, 14, and we are told that every time it goes over 1, it goes up 3. We could continue if we wanted to, but what we're interested in is the y-intercept, and the y-intercept has an x value of 0. So we don't really care to keep going past, 5, 6, 7, 8. We actually want to backtrack to 0. So we need to work backwards here. And what number when we added 1 to it gives us 3? Well, that was 2. And what number when we added 3 gave us 14? Well, that was 11. We can backtrack one more time for 8. We can backtrack one more time for 5. And so our answer here is, the y-intercept here is 5. Okay, next up. What is the y-intercept of this equation? So this one, we are not given a table or a graph. We are instead given the equation. But notice here how we have the slope. We have a point on the line, right? This is the point 2, 16, right? And I guess we are calling it b now. In this equation, b is typically what we use for the y-intercept. That's kind of its variable. B is kind of the most common name for the y-intercept. All right. So if 16 equals 3 times 2 plus b, it's important that we don't get too caught up in all these variables being added and multiplied, but instead we just look at this as an equation to solve, right? 3 times 2 is 6, right? We can use BEDMAS on that. And then we can use inverse operations to isolate b, right? We move the 6 over where it becomes negative, and 16 minus 6 is 10. And there we go. So 10 is your y-intercept. This is another way we can solve for the y-intercept just by using our algebra skills and the skills that we learned how to solve equations in the last unit. All right, a line has a slope of -1/2 and passes through 12, -4. What is the equation of this line? There are many different ways you could solve this problem. If you wanted to, you could kind of break out the table here. We know that the rise was -1, or the -1 going this way. And we know that the run was 2, right? So we could work backwards almost the same way that we did last time. And that might work for a lot of you. The graphing, it might be a lot to graph this thing, but you totally could plot a point at 12,4 and then try to work backwards with a slope of -1 over 2. The table works too, or we can just set up our y equals mx plus b equation, right? Because the slope is -1/2, right? We're told that in the question. And we know it goes through the point 12, -4, where x is 12 and y is -4. And look, now we are just doing the same as question 3, right? So what's -1/2 of 12? That is -6. We can move -6 to the other side where it becomes positive. And 2 is your y-intercept. Easy as that. If you were to have done it the table way, you're likely working backwards like this: 8, -2, 6, -1, 4, 0, 2, 1, 0, 2. It does take a lot because here we had to do like 6 iterations, but you totally could continue that rise and run pattern in order to find it that way. And note that it did not ask for the y-intercept, it asked for the equation. And so we just put in our slope as -1/2, just like the question said, with a y-intercept of 2, right? Remember, it did ask for the equation, not just the y-intercept. Okay, next up. What are the pros and cons of each method, graph, table, or algebra, for finding the y-intercept given a slope and point? So let me form kind of a T-chart here, right? So we'll call this pros, cons, and then we have graph, table, algebra. All right. I would say that the pros of the graph are it's very visual, right? We can see a little bit easier what's happening, and it's a little bit easier to extend a graph in either direction, right? We'll say easier to extend, right? The cons with the graph is we have to draw a graph. If we don't already have one, it will take a long time to make one, right? So sometimes drawing, like if the question doesn't give you a graph, it might not be convenient to draw it. All right, the table, what's the pros of the table? Well, I think it's easier to see the pattern in a table. It's easier to see the pattern here. It's more clear what the rise and run is, and you can find it without even really worrying about rise and run. You can just find, okay, what's the pattern in each column? And you can use that to extend. The cons is, because it's just a list of numbers, it's hard to know where you're going, right? It's hard to know where the y-intercept is, right? Think about how we did it in the table last time, right? We put in 12, -4, but the point we needed actually ended up being way earlier than what we found. We had to extend it 6 times, and that might not always be what you want to do. It might be easier to do something else. So the table is nice because it's just patterns, but sometimes it's hard to kind of predict where the point you want is going to be. And what if these numbers were odd, right? Then we wouldn't have 0. Then we'd have to kind of be working in between, right? So sometimes it's hard to exactly map out what you want here. And then algebra, the pros are your equation is already built. The equation is built, and I think the algebra way is also very straightforward, right? It's algebra. For a lot of you, you might be able to get into a routine, get into a rhythm with it, and then it not take too long. And what I mean by the equation being built is we already had our slope inserted. All we had to do was insert the b to be done. The cons with algebra is if you have weird numbers, the algebra might be tricky, right? If these numbers don't work out perfectly clean, the algebra might be a little bit difficult to do, and that could cause some problems. Okay, and for this one, make the equation here. So the first thing we can do here immediately is make the slope. The slope is rise over run. We see that the rise is 4, the run is 2. And so 4 over 2 is 2. So the slope is probably the easiest part once we're given the rise and run. But how do we find the y-intercept? We can use any of the methods we've done. We can use the graph, although we'll have to kind of really extend it here. We can use the table, we can use algebra. Let's use the table here. Do a little bit more detail as to how we could use the table. So we have a point, 15, 26. We need to work backwards to figure out what it is at 0, okay? And so we know that every time it gains 4, the x values gain 2. So let's work backwards. This would be 13, this would be 22. Then we have 11, 18. We have 9. Maybe it might be easier to do all your x's. 7, 5, 3, 1, -1. And then 14, 10, 6, 2, -2, -6. Okay. Now we're in a bit of a pickle because we have this section here. And 0 isn't one of the points that our table gave us. But can we work in between? Yeah. Halfway in between -1 and 1 is 0. Halfway in between -6 and -2 is -4. And so that gives us our y-intercept. If you've done it with algebra, it's a very similar process. You just input 15 for x, 26 for y. All right? And that's your consolidation video for Unit D, Lesson 5.